In this video, we'll be looking at functions. Now, in mathematics, a function is an expression, rule, or law that defines a relationship between one variable, that is independent variable, and another variable, that's the dependent variable. Now, suppose we have that to each element of a set A, there is assigned a unique element of set B. The collection F of such assignment is called a function. So sometimes we define it as a mapping A into B. We say A into B. We denote it mathematically, we write it as a function of mapping A into B. Now, A is the domain and B is the co-domain. Now, there is what we call a relation. A relation is a function if for each input x, there is exactly one input of y. So the domain of a function is the set of points of a set for which the function is defined. A function is said to be defined at any point where it has a finite value. For example, if we say determine the domain of the function, or let's say determine the domain and the range of a function f mapping R into R such that, let's see, for the first one we have that f of x, or we call it y, is equal to, let's say, 2x over x plus 5. And let's say f of x is equal to x squared over square root of x squared minus 4. So how do we solve this? If we look at the first one, you will notice that the answer will be undefined when the denominator is minus 5. Because if the denominator is minus 5, we'll have denominator minus 5 plus 5, that is 0. And so it will be undefined. Because of that, the domain of this function will be all real numbers except minus 5. So we can write it that the domain of f is all real numbers except minus 5. For the second one, we have x squared over root x squared minus 4. Now, this function is not defined when x squared minus 4 is either equal to 0 or less than 0. And the range x squared must be positive. And because of that, x squared root x squared minus 4 also must be positive. Now, let's have one more question to find the domain and range of this. What we know is that the domain, for us to find the domain, f of x will be undefined if this x equals 2. So if it is equal to 2, it means 2 minus 2 will give us 0. So it will be undefined. Because of that, the domain will be all real numbers except minus 2. Except 2. Except 2. It will be all real numbers except 2. And for us to get the range, we have the numerator to be x minus 2. The denominator, we need to make it look like this by multiplying with minus. So these can cancel out this. And because of that, the range is minus 1. Now, what that means is that f of x is a constant function. Now, if f and g are functions with domain of f and domain of g, where domain of f and domain of g are subsets of the same set, then it means that f of g of x, fg of x is equal to f of x, g of x, and also f over g of x is also equal to f of x over g of x, provided g of x is not equal to 0. For example, if we have that if f of x is equal to square root of 2x minus 1 and g of x is equal to 1 over x, find f plus g of x. So for us to get that, we've already said that fg of x is equal to f of x and g of x, because if you use x to open up the bracket, that is what you get. So okay, let's also add another one to get f dot g of x. Let's also find that. So working on this, we have that f plus g of x is equal to f of x plus g of x. Haven't done that. Now f of x already from the question is 2x root 2x minus 1. So we have root 2x plus, minus 1 plus g of x. The g of x given to us is 1 over x. Now, this thing is the same thing as writing it as root 2x minus 1 plus 1 all over x. For the second question, which happens to be f dot g of x, now we said it is equal to f of x times g of x. Now, what it means is 1 over x times root 2x minus 1. And if you multiply that, 1 times this gives us root 2x minus 1. X, this 1, x times 1, x. That's the answer. We have composite function. Composite function is when you take one function and put it into another function with respect to x. For example, if f of x equals 6x minus 3 and g of x, g is 4x squared plus 2x minus 1, evaluate f of g. Now what we need to do is that f of g is saying f of g x, which means g of x already is 4x squared plus 2x minus 1. What it means is that, let's write it, 4x squared plus 2x minus 1. What it means is that for this is f, anywhere I see x, I remove it and replace it with g. So, which is 6x. Instead of x, I'll say 4x squared plus 2x minus 1. Then minus 3. That is there, minus 3. Therefore, we can simplify. Opening the bracket, we say this into this, 24x squared. This into this, plus 12x. This into this, minus 6. Then minus 3. We can resolve this place. 24x squared plus 12x minus 6 minus 3 is minus 9. So this is the answer. Do well to subscribe to my channel if you haven't. Thank you. We have what we call special functions. So we're going to look at them and their graphs. The first one is the constant function. Here y is constant. So f of x or y is constant. What it means is that y has only one value, which is c, in its range. So the image of every x is just c. So if this is y and this is x, so it's just, so y equals c. So the next one we have is the identity function. Here y is equal to x. What it means is that its domain and range are equal. So if we have y and we have x, so the graph goes this way. So y is equal to x. Another one is the one we call Heaviside function. Heaviside function is if we have that y is equal to a set of, let's say 0, x is less than equal to 0, or we have that 1, that x is greater than 0. So if we start, let's say this is y and this is x. So at 1 it keeps going. So this is how it looks like. Another one is the absolute value function. So y is absolute value of x function. What it means is that we have that x is less than 0 from minus x is also less than 0. So the graph y and x, it just comes from here this way and it goes this way. So both the positive value of y, so that's how it goes. Then the last one of that is the greatest integer function. The greatest integer function goes, the graph goes this way. Let's see. So if we have 1, 2, 2, here is x, axis and y. So if you haven't subscribed to my channel, please do so. Just click the subscribe button. Thank you.